Hello everyone, I welcome you all for the course Data Science. We are in data cleaning or data wrangling or data transformation we are in. And then the last lecture we had seen what are the problems faced while handling large volume of data and what are the solutions and what are the tips. What are the general tips? Then once we solve the issues in handling the large volume of data, then next part is data wrangling. Data wrangling is converting a raw data into a usable format. So there are six techniques we have seen with examples, and what are the tools or what are the Python tools that have been used to perform this wrangling process we have seen. Okay, and then in that in data wrangling we have data enrichment. That is, if we don't have enough data, then we have to merge. So we'll see that in today's class. So the topic is the combining and merging data sets. Okay, so how do we use Python tool to combine or merge any data set? So in Python, we have pandas.merge, pandas.concat, combine first. So these are the functions or methods that are used to combine or to merge any data sets. Okay. So, so regarding merging, we have four different joins. One is inner join, outer join, left join, and right join. So let's take two data frame, df1 and df2. So I want to merge df2 to df1. So we have to put df1, and then I'm going to use this code merge. So I'm going to merge df2 with df1. So this is the code. Okay, this is the code for this. So if you use this, automatically df2 will be merged with that. Okay, but here I have not mentioned whether the merging is inner or outer or left or right. Suppose if it is not mentioned, then the default one is inner join. Okay, but if you want to perform outer or left or right, then you have to add that feature in this. Okay, so let's see what is inner join. So here these are the two data frames, and then one data frame is you have some customer ID, name, product, and quantity. And in the second data frame, the same, some names are there or new names are also added, because this is one data set, this is also one more data set, but here one more column is added, which is membership. Okay, so in this, if I want to perform inner, first I have, because this inner is performed based on customer ID. So you have to check, if you take one customer ID 101, you have to check that 101 should be in both the data frames. So you have 101, here also 101, so 101 is taken. Then if you take 102, then you have 102 is there, so you have to take 102 also. And you have 103 here, here also 103, then you should take 103 as well. But 104, 105 is not here. Okay, so you have to take only the elements or only the IDs which are common in both the data frame. So accordingly, so 101, 102, 103, and then for this 101 you have to write the name. So name is Alice, Bob, Charlie, and then for that Alice, your product is laptop, mobile, and tablet. Quantity also 1 to 1, and you have to add the city as well, New York, Chicago, Los Angeles, because you have merged membership. So now your columns have been increased from 3 to 5 now, but the rows are only 3. So inner joiners only if the elements are common elements, or on which column you are going to perform this merge. So you have to take that, in that the common entries should be taken from both the data frames. So this is how your inner join performs. So inner join means you don't need to mention, the default one is inner join. So let's see that. See here, you can see, these are the common customer ID, the name, laptop, product, quantity, city, and membership. Okay, so this is called as inner join. Then what is other than this is the command. So df1 dot merge df2, and then on which you are going to apply this merge customer ID. That's why on customer ID. How we are going to perform inner. Okay, the next thing is the same thing like df1 dot merge df2 on customer ID, and how we are going to do that outer. So in outer, you have to just combine whatever in df1 and df2. You don't need to look for any common entries. Okay, so in the last, the previous one we have seen 101 to 106 you have. Okay, but in the next entry you have 101, 102, 103, and you have 105 and 107. So when you combine everything, then you have all the entries. So whatever customer ID or even new or one ID is in DF1 or the other ID is not in DF1 but in DF2. So you have to combine all the customer IDs in one data set, and then according the names will be there and according the product. But for certain items, for example, for 106, 107, it does not have quantity. So in that case, the values are missing. So you have to put NaN value. And here also 104 and 105, the city data is missed. So you have to put NaN value. So whatever is missed, then you have to put NaN value. Okay, so in this join, in inner join, you will not have a chance for NaN value because only the common entries should be taken. Whereas in outer, all the entries are taken. That is why there are chances for NaN value. So this is inner join, and next one is outer join. Okay. Next one is left join. So the same thing, df1 dot merge df2 on customer ID, and the join is left join. Left join means df1. So you have to give priority to df1, that whatever is present in df1 that has to be entered. So you don't need to consider df2. So the df1 customer IDs are 101, 2, 3, 4, 5. Okay. And in df1 we have name, product, quantity. So there is no NaN value. But your city and membership is in df2 only. But for the common items you have values. For the uncommon thing you have to represent NaN value. So left join means if you want to concentrate only on the left one means, so in that case you have to use left join. Similarly, right join means df2 is important. So this is for df2. Okay, so this is you have to give importance to df2, that is right. If you are giving importance to df1 means that is left join. So since it is right join, whatever customer IDs are present in DF2, you have to mention everything. And you have city and membership data, but this product and quantity is not there. So those things are replaced by NaN. So this is how you have to perform joins. So the important takeaway are use inner if you only want matched rows. If you want to collect only the common items. Suppose if you again we'll take the placement data. So if you want to collect I mean, the students who got more than 9 CGPA. So that is common. There are few students in all the department. Only those students you have to select, means then you have to perform inner join. So use inner if you have, or if you want only matched rows, then use outer to keep everything. So I want to know who are all applying for placement irrespective of their grade. So that is outer join. And use left one if df1 is important. Suppose if you are merging mechatronics with triple E. Triple E means, so you have to give, I mean, you need to include all students, means then you have to do left join. Okay. Or if you want to give importance to triple E means you have to do right join. So based on your requirement, you can perform. So this is how it's presented. So this is the common elements, and then this is left outer join. Only the left part is taken. This is right part. Then this is the entire part. Okay. So this is the summary table. In the inner join, you will not have chance for NaN. Okay, NaN is not there. And for outer join, all the elements have to be taken. So there is no common rows. And if you take left join, then you have to keep all df1. Yes. Then it includes NaN. Yes, of course, because some entries are not there in df1. So you have to put NaN also. But uh, it has to keep all df2. No, there is no way, because it's left join. And is there any common rows? No. Okay. Similarly for right join as well. So this is how we can perform in merging two data set using Python. Okay. And we'll see some more examples. So here, let's say one data frame. So here the data frame, this column is key. Okay, column, and the data, another column is data one. So the data one is range 7. So you have to start from 0 to 6. Okay, this is one data. Another one is you have to fill BBB, ACAAB, like that, and automatically index will be given. So this is for this. Okay. The next data frame is you have key, and then this is given, and data 2 is also there. So this is your second data frame. Okay. And when you combine, so you are using this command pd dot merge df1 comma df2. Okay, so in this nothing is mentioned, so it is inner join only. But you have to take the reference as df1, so you can take the first element. Mm, First element is, or if you, because it is sorted only, you have to take a, first check a, that a should be in df1 and df2. Yes, a is here also a, so you have to put that a. Okay, and for that a, accordingly, what is your data 1 and what is your data 2, you have to fill it. Okay, and similarly, since you are giving importance to df1, so you have to take all the a's. Okay, so you have to take all the a's, and accordingly you have to fill the data, and the next one is b. But you should not take C and yeah, C. You should not take C because C is not in DF2, and you should not take D because D is not in DF1. So this is inner join. Only the common keys have to be taken. Okay, this is one example. And one more example is, so here one data frame DF3 and another data frame DF4. Okay, so we are merging DF3, DF4, and you have to consider L key, and your right key should also be on. Okay, so I mean, this has to be taken as a column. So L key and right key, and data 1 and data 2. Then you have to take accordingly. L key means it's already your that column name is given, so you have to give it in the order. So it has A, B, but C is here, but that C is not here, so C is not included here. Okay, whereas your D is not present in L key, so the D should not be here, because here the join is not mentioned. That is why it is inner join. Only the common elements are taken. Okay, so here uh, the previous one also we have seen, it is on key because you are going to use the key element to merge it. Okay, and so this is the explanation. So what is left, what is right, and then how on means on which column you are going to apply this merging, and then left on, right on, left index, right index, sort, suffix. So these are the descriptions, or these are the arguments that are used in merge. Okay, so one more example. So we can take two data frame. First data frame is about batting status. So you have player, team, and runs. So we have given that data frame. And another data frame is about bowling. So you have a player and this thing. Okay. So now we'll do one. I mean join. First join is pd dot merge df1 df2. Here the join is not mentioned. So obviously it is inner join. Inner join means you have to compare the common names, because if nothing is given, then the player on because your merging should be done on player only. So if you compare these two, the common names are Smith root, Smith root, so that is given. So Smith root here, yeah, Smith and root, and their team name, and then how many runs they have scored and how many wickets they have scored. So this is called as inner join. Okay, so this is the merged one, and then in detail it is given, like on, I mean on which you are going to merge is player, and how you are going to do inner. So both are same. If you give both the comment, the output will be like this. Okay, and then the next one is, yeah, this is in inner join, and the next one is left join. Okay, so left join is already we have discussed. Batting statics should be given priority. So you have to give all the names, Virat, Rohit, and the Smith root. So you have to give all. Okay, you have to give importance, and then the team is the same and runs is all the same. But you will not have this team by information. That is why it is NaN. Okay, but for Smith and root it is common, and wickets are also not for Virat and Rohit, so that is why it is NaN. Okay, this is left join. Okay, the next one is right join. So in right join, give importance to the bowlers. So in bowlers, you have Smith, Root, Bumrah, and Stark for him, the runs on NaN values, runs and team X on NaN values, but other data is there. Okay, and next one is outer join. You have to combine everyone. I mean, both Smith and Root are common, and the extra players are Rohit and Virat in bowler. Sorry, in batting, and Bumrah and Stark is the in the bowling part. So you have to combine everything. So this is your okay. In this case, we are going to perform outer join, but we are going to use left on and right on, which means in the for the DF1, the player is replaced by batsman, and for the DF2 it is just player only. So yeah, batsman is included, player is included, but all the other teams or all the other informations or with respect to outer join, which means you have to include everything. And one more thing, so we have, so here we have the index values are 0, 1, 2, 3, 4, 5 likewise, whereas in this case you have to set index. So set index like batsman, so you have to use the batsman data as the index. So that's why in place true. So in that case your 0, 1, 2, 3 will be replaced by the batsman data. So you have to set index. Similarly you have to set index for DF2 as well. So your players, so players are for DF2, the players are Bumrah and Root, Smith, Stark. So those guys are taken as index. So that's why your index is Bumrah, the players or batsmen or considered as the index. That is why in place true and set index. Whereas in the previous case 0, 1, 2, 3, the index is there, okay, but that is replaced with the batsman or player. So that's why this is the index. Then here you are using left index true and right index. So this is left index for this and right index for this. So that is true, which has to be included. And it is outer join means you have to include everything, all entries. Okay. So this is your outer join. And one more example is how do you merge on index? Okay, how do you merge on index? Previously we merge on particular columns, but how do you merge on index? So let's take one example. So here for this data frame, key is the column and value is the column. So accordingly we filled. And in the second data frame, group value is 3.57 and index is given A comma B. Okay. So now you have to merge pd dot merge. So left one and right one, left on key and right index true. Okay. So you have to use the right index true and you have to use the left on key. Okay. Left on key means this has to be taken. So that is why in the key you have A, B, but C should not be taken because C is not in this data frame, second data frame. That is why you have to merge on key so that key has to be taken. Accordingly, the values are printed. So values are printed. And then since you are merging with the other data frame, so that values have to be taken. Okay. So already if you have A means it has to be printed as 3.5, B means 7. So that is why it is printed. Okay. So you are going to merge left one this data frame, right one data frame, and then how will you merge based on the key, this left on key, that is you have to consider only this key. So that is printed and you have to use right index true. Okay, so right index true means, so for this is the index A and B is the index, so that has to be taken. Okay, this is merging on index. And the next one, next combining data set is concatenating along the axis. Either we are going to perform column wise or row wise. Okay, so this one example, you take an array, then arrange the array from 0 to 11. Okay, and then the shape is 3 comma 4, so there is 3 rows and 4 columns. So you can arrange like this is one array, and I want to concatenate, I want to concatenate with the same array. Okay, in that case here it is axis equal to 1. Axis equal to 1 means it is horizontal stack. Horizontal stacking means already you have this 1, 0, 1, 2, 3, 4 like that. So this is array and then this is one more array. This is array, this is one more array. Both has to be concatenated, but in what fashion? Horizontal fashion. This is horizontal fashion. So that has to be okay. If nothing is there, then it is considered as column wise stacking. Okay. So this is for column wise, same thing. So first you have to take an you have to make an array, then that has to be reshaped into 3 comma 4, but you're concatenating with respect to axis equal to 0. So this is one set. Okay, this is one array, this is one array, but how do you concatenate in this fashion? X equal to 0 means, so this is a vertical stack. Okay, so this is also one type of merging. So for concatenating along an axis, so we need to know what is the object, what is in which axis it is going to be performed, and then join axis, keys, the levels, names, verify the integrity, ignore index. So these are all possible in this concatenating along an axis. So let's see one example. So here the data frame is here A, and then under A you have 1, 2, and then the index is A and B. So this is one data frame. And the second, this is DF1 data frame. df1, and then second data frame is you have again a, and then a entries are 3 and 4, and then index is c and d. Okay, so now you are concatenating these two, but you have to ignore the index. Ignore index equal to true. That is, we have to ignore the index. So which is you should not take A, B, C, D. So the output is 1, 2, 3, 4. So this is the after merging, which means ignore index. So that has to be true, which means the index A, B, C, D should not be entered. So this is first this, and then second one is here also the same. So you have A, which is 1, 2, and then index is AB. This is one data frame. Another data frame is A is 3 and 4, index is C and D, and this is the index. Okay. So now we have to concatenate. Means here they did not mention ignore index equal to true. So your index is A, B, C, D, and then A is 1, 2, 3, 4. Okay. So you just check this output with this output. So here index, ignore index equal to true, but here it is not. So that is why index is taken. Okay, so in this way also you can merge, or this merging is based on index. Okay, so next combining data with overlap. Okay, for that we have to use this combine first. Okay, so already in the first slide we have mentioned pd dot merge. Okay, next one is pd dot concat. Okay, next one is combine first. So in pd dot merge we have seen inner join, outer join, left join, right join. In concatenate we have seen, and the concatenation is based on index. Means how do you do, we have seen that also. And suppose if you use combine first means, so actually we'll take this data frame first. So df1 is, you have a column. In a column you have first data, and then none data, and then 3. Okay, and next one is b, and it is none, and 5 and 6. For this the index is a, b, c. Okay, this is one data frame. And then next data frame is here also you have index a, b, c, and then a is 10, 20, 30, and B is 40, 50, 60. Okay, when you combine these two, combine first means first if you have any NaN value, that will be replaced from the uh, data frame which it is on which it is going to be combined with. So here if you take this arrow, so you have one data, so that is why wow, it will not have 10. Okay, because you're combining, see the code, your df1 dot combine first of df2. So you have to write df1 as it is. So df1 is 1, none, and 3. But since it is combined with df2, in the place of none, you have a 20 value. So the 20 is replaced. So this is called as combined first. Similarly, in this 5, 6 remains the same, but this has to be taken from the other data frame. Okay. So their none is replaced with this 40. That is why it is called as combine first. That is, combine first in pandas is used to fill the missing values. So first it will concentrate only on the missing values. So fill the missing values in one data frame with values from another data frame based on the index. So this is how your combining data with overlap works. Okay, so one more example is, so here one data frame which is a, b, c, and then the values are 1 and nan, 5 and nan. Okay, and for B it is nan, and then 2 nan, and 6. For this case it is from 2, you have to start from 2, and the step size is 4. Okay, so 2 plus 4 6, 6 plus 4 10, 10 plus 4 14. Okay, so this is df1. And then for df2 you have a and b, and the values of 5, 4 nan, and then 3, 7, and here nan, and 3, 4, 6, 8. Okay, so these are the two data frames. So I'm going to combine df1 dot combine first df2. Okay, so this is df1, and then this is df2. So we have to take this. Okay, so we should have a, b, c. So a, b, c, and then for a it is 1, and for this we don't have any value. So you have to pick this value from the other data frame, which is 4. Okay, that 4 is replaced, and then you have 5. Okay, and for the next case 3 is replaced. So 3 is replaced, and since it is combined, the last one is also taken. This is 7. Okay, similarly for b, So for B, here also nan, here also nan, so there is no change. And next one is 2, yes 2, and for this you have nan, but you have 4 value, that 4 value is filled, and you have 6, and then the 8 is from DF2. Similarly, for C, you have nan here, but the C value you have uh, sorry, the C, yes, you have 2. Okay, so the 2 is same, 2, 6, 10, 14 is there, but you will not have the last value, but the last value is not in DF2 also. That is why it is replaced with NaN. So this is how your combined first works. So combined first means first it replace the NaN value, okay, with the values from the other frame. Okay, and the next one is reshaping. Reshaping means you have to change the looks, okay, change the size of the array. Okay, so this is called as reshaping. So you can, so this is the thick array, so that has to be converted into thin array. Okay, so this is called as reshaping or pivoting operation. So there are a number of fundamental operations of rearranging tabular data, and they are all referred as reshaping or pivoting. Okay, so we'll see one example. So in this, we are using stack method and unstack method. So stacking means this rotates or pivots from the columns in the data to rows. Okay, so this is here one column, and then this is our rows. So here we are increasing the rows. So here see, there are 3 rows, but the rows are increased to 6. So if you are increasing the rows, then that is called as stacking. Okay, but if you are reducing the rows but increasing the column, means that is unstacking. So unstacking means this pivot from the rows to columns, rows into columns is unstacking, and columns to rows. So column means like this, column to rows. Okay, this column are converted into rows. So this is called as stacking. Okay, or one more function is melt. Melt also can be used. So it converts wide to long format. So wide means you have columns. Columns are more, and those are converted into rows. Okay, so that is wide to row. Wide to row means columns are converted into rows. And pivot means long to wide. Long means you have more rows. So rows are converted into columns. So this is called as wide to long and long to wide. So melt function and pivot function are used. Okay. So in this code, we'll see how stack works. So we can take one data frame. So here in this data frame, maths are entered twice, which means it's a common subject. For each maths, we have score and grade. So that is why math is here, then you have score and grade. Okay, and then the score is entered, grade is entered. Similarly for science, you have score and grade, so you have science, score and grade are entered. Then you have to give the index. So index is Vyani, Babu, Chinna. So when you print this, so you will get this kind of data frame. Okay, so now we are going to apply this stack function. Okay, so the stack function is, you're going to convert columns, you're going to convert columns to rows. Okay, so how do we do this? So if you apply stack, so this is the original data frame. In this your column, so you have to take the innermost column. Okay, so this is the outermost column, and then next column is score, and the next column is grade. So which is the innermost column? Grade is the innermost column. So that grade column is converted into row. Okay, so that's why row. And then the next innermost column is score. So the score is given. Okay, but this is not changed. Only the innermost column are converted into rows. Similarly for this, the innermost is grade, and then grade and score, and then here for Chinna also same. So this innermost column are converted into rows. In rows we have Vyani, Babu, and Chinna. So that is why this columns are converted into rows. Okay. So now here you have 3 rows, but it has been increased to 6 rows. But see the column, you have 1, 2, 3, 4 columns, but here only 2 column in this. So you're converting the fat one, I mean thick one, thick to thin. So for that you have to use stacking. Okay, and the other data are similar to this. So what is stacking? What is stacking? Moves the innermost level. Okay, what is it's default? Default is move the innermost level. Okay, suppose if the level equal to 0, if they mention level equal to 0 means you have to take the outermost level. Okay, so what is the outermost in this math? So you have to take math and science. Okay, so see, based on the level, that particular column will be taken. If it is default means innermost level, if it is not default or level equal to 0 means outermost level is taken. So this is why means is given here. So df dot stack, and this is the stacked one. So this is how it appears. Okay, so in this, it moves the innermost column index to row index, making the data frame taller. The remaining column levels stay as columns only. Okay, this is one example. And one more example. So here I have applied level equal to 0. So level equal to 0 means you have to take the outermost. So what is the outermost? Math, science. So maths and science are common for all these guys. So here you have to put Vyani math science, Babu math science, Chinna math science, and the other columns stay as it is. Okay, so based on the level, so default means innermost, level equal to 0 means it is outermost. So this is called as stacking, which converts columns to rows, which means the fat one will become thinner one. Okay, and the reshaping with the hierarchical indexing. So let's take one data frame. The data frame is mean you have to take 6 0 0 1 2 3 4 5. So that has to be arranged in two rows and three columns. So 0 1 2 3 columns, 3 4 5. So two rows and three columns. Okay, and then indexes, so that's why here see 0 1 2 3 4 5. Okay, and the index is index equal to pd dot index Ohio Colorado. Okay, so for this you have to give the index for this. So one is Ohio and Colorado, and then this index title is state. So state is given. Okay, and for the number, I mean for the column pd index, so this is column index, this is index. So for index it has to be entered here, and for column it has to be entered here. For columns, pd dot index of 1 2 3, and then at the title is number, so name is the title. So this is how your data frame is framed. Okay, now we are going to apply this reshaping. Okay, so now here already we have discussed this. Okay, so now we have to apply this stack. Okay, so data means this is the data, this is the data. Now you have to apply stack. So stack is converting the columns into rows. Okay, so and then here nothing is mentioned. So here the innermost is I mean this number only. So it starts from uh, 1 2 3 for Ohio Colorado 1 2 3. So now your thicker one is converted into thinner one, which means column to rows. That is why stacking. Okay, and then unstack is converting rows to columns. It is thinner one or converted into thicker one. So data dot stack. So this is already stacked, and then that has to be converted into the original format unstack. So these 1 2 3 will be converted into columns. Okay, and another one is level unstack. Okay, so let's take this example. So here you have one column left, so that is left, and then so left is the result, and then right is result plus 5. For example, if you take result as 0 means right will be 5. If you take 1 means it is 6, 2 means 7. So likewise we can frame the data, and the columns are pd dot index. So columns, because this is column name is left and right, and then the name is site. So the title of this column is site. Okay, but this is already given in Ohio State and Colorado. For these thing you have to give 1 2 3 1 2 3. So this is it's already unstacked. So if you sorry stacked, so you have to unstack it. So for that, apply just unstack, and then your unstack is based on state. Okay, since your unstack is based on state, so these are the states. Ohio and Colorado will be moved as columns. It was rows before, but that is moved as columns, but others remains the same. So the data will be moved accordingly. So this is called as level. So let's take one more example. This data frame is already I had explained. So this is the data frame. First, I have to unstack. So for unstacking, so I have to put this left, right remains the same. Unstacking means this rows are converted into columns. So you have Ohio, Colorado in left side, Ohio and Colorado in the right side. and then the left title is site, and then this title is state, and you have number. So number is 1, 2, and 1, 2, and 3. Okay. So for this, for Ohio it is, see here, for Ohio it is 0, 1, 2. Okay, 0, 1, 2. So here this we can have 0, 1, 2. Okay. And for Colorado it is 3, 4, 5. 3, 4, 5. Okay. And for right Ohio is 5, 6, 7. And for right Ohio is 5, 6, 7. And for right Colorado is 8, 9, 10. Okay. So this is called as unstacking. And now I have to stack with respect to side. So what is the side here? So left, right. So now left, right, or because it is stacking. So left, right columns are moved as rows. Okay. So the same thing, but you have, I mean, this 1, 2, 3 remains the same. So already we have this number. So this 1, 2, 3 remains the same. In addition to that, this side is also considered as rows. Okay. So 1, 2, 3 remains the same. And then the side left, right for 1, and then left, right for 2, left, right for 3 is also given. So here for Ohio, so it is the left value is 0, and for 2 the left value is 1. You can fill accordingly. For 3 you are taking only left. Okay. And for Colorado, left value is 3 and 4 and 5. Okay. Then we'll take right of Ohio. Right of Ohio is 5, 6, 7. Then right of Colorado is 8, 9, 10. Okay. So likewise, we can both stacking and unstacking. So what is stacking? Stacking means columns are converted into rows. Okay. Or I can say thick. Thick is converted into thin matrix. Whereas unstacking is rows are converted into columns, or thin ones are converted into thick ones. So this is called as reshaping. So that's all for today. In this class, we have seen what is merging. In merging, we have pd.merge and pd.concat. Concatenation means you can merge the two data sets with respect to axis. Axis 0 means column wise, axis equal to 1 means horizontal stacking. And regarding merge, we have inner join, outer join, right join, left join. If you want to collect only the common elements, go for inner join. If you want to take all the elements, means that you have to go for outer. If you want to conserve only the leftmost data frame, means use left join. And if you're concentrating only on right data frame, means you have to concentrate on, you have to take right join. So this is pd.merge and concatenate along the axis. And third one is combine first. Combine first means first the nan values have to be combined or have to be filled with the other data frame which has the values. If the other data frame is also not having the nan value, means then let it be as nan only. And this is your merging. And next one is stacking. So stacking is you can convert thicker fat thicker or fat matrix to thin matrix. So if you want to convert columns to rows, okay, columns to rows means, so which is called as stacking, and rows to column is, that is unstacking. Okay. But you have to mention on which column you are going to do stacking and unstacking. If you're stacking means you have to choose the innermost column which is axis, I mean the level equal to 1. And if level equal to 0 means, then you have to take the outermost column that has to be converted into rows. Okay, that's all for today. Thanks for watching.